Okay, water skier has a mass of 73. That is her inertia. Find the magnitude of the net force acting on the skier when she's accelerated from rest to a speed 11 meters per second in 8 seconds. As soon as you see time, speed, or distance, that means old school. So I set up the old school Sudoku. She went from rest to 11 in 8 seconds. And the secret passageway from old school to new school is not time right now, but acceleration. So we need to find the acceleration to take it into new school. And love the Sudoku because you can see that this row is complete. So we're going to use the velocity function. And you get an acceleration of do I just have the first? I think I just did part B. 11 divided by 8 is 1.375. And then again, so we've got our secret passageway to new school, and the new school says the sum of the forces equals MA. Now, most of the problems you'll do for me, I will give you the tension and you'll find water resistance. Like I find that more helpful to know what each of these things are individually. But this question says find the net force, which is technically tension minus force of the water resistance together, just like when we did fan minus friction at the beginning of the year. So they're just saying find the combination. We don't care how much tension is, how much air resistance is, we just want to know what's the net result, okay? Because that's what's pushing her forward. So just different way of thinking about it. So the net or total force is 73 times our acceleration, which is almost 100 perfect even. So 100.4 newtons. Okay, because again, that's all that matters is, that's what they're asking, net force. Now, she doesn't feel 100 newtons. She feels whatever this tension is in her hands. She doesn't feel the water resistance. But we don't know any of that. All we know is tension minus water resistance is 100. So that's it. That's what that means is she's accelerating as fast as if there were no water resistance and the tension were 100. Okay, so that was question A. Find the net force. Question B, she lets go of the tow rope and glides to a halt in 21 seconds. Okay, I will pause and put that information down there. Okay, so this is like when we did restart the clock. Oh, we didn't do restart the clock problems this year. Okay, so she lets go of the tow rope and now there's just water resistance. So her initial speed is 11, her final speed is 0. It took her 21 seconds to come to rest. We still have the velocity rho filled out, so V equals V naught plus AT. She comes to rest, equals 11 plus A times 21. So A is, sorry, you're going to subtract 11 from both sides. Let me move this up a little bit. So subtracted 11 from both sides. So A equals negative 11 over 21 because she is slowing down going forward. So that is 0.524 meters per second squared. Sorry, negative. All right, so again, that is the secret passageway to the new school. So the new school, remember that number? The new school is F net or sigma F equals MA. Sorry, just already have that Her mass hasn't changed. She still has 73 kilograms of inertia. And keep the minus sign because the minus sign is important. It's going to tell you the direction of the net force. So 73 times negative 0.524 means that the net force on her is pushing her to the left with 38 newtons. Check your work. That makes sense. In part 1, the net force was 100 newtons to the right, and she went from 0 to 11 in 8 seconds, right? So since the net force was bigger, didn't take her as long to get up to speed of 11. So it meant that tow rope was really strong. And then she slows down, and the water resistance is not as strong, and so it takes her 21 seconds to slow down, meaning there's a smaller net force pushing her back. Okay. Awesome. Hope that made sense. See you in class.